Okay, let's jump right into this explainer because what we're looking at today is just absolutely mind-bending. Imagine for a second that you're stepping aboard the Archimedes-IX. It's this hyper-advanced, totally autonomous exploratory probe launched from Earth way out in the late 23rd century. We're taking a jump through an artificial wormhole into an uncatalogued galaxy, a staggering 13.2 billion light-years away. Our destination is the Ovid-9 Supercluster. Now, we are traveling to a region of the universe so incredibly ancient that star formation has literally long since died out. All that's left are aging red dwarfs, cooling white dwarfs, and these wandering cosmic ghosts. And that is exactly where we find Erebus. It's a massive rogue gas giant just drifting through the eternal dark. Now, here's the thing. We didn't actually come here looking for life. We came to study physics. But what Archimedes-IX found deep inside this frozen world, it's going to completely shatter everything we thought we knew about biology.
And I think this quote brilliantly hits the nail on the head regarding the core mystery we're unraveling today. Life is an emergent property of thermodynamics. For centuries, we've looked up at the stars and basically just searched for our own reflection. We wanted rocky worlds, warm suns, gentle atmospheres, and liquid water. We sort of assumed life was this fragile, delicate little flower that could only bloom in a perfect, tepid garden. But what if it's not? What if life is simply the universe's ultimate mechanism for increasing entropy? What if life just isn't picky? What if it'll seize upon absolutely any chemistry, any physics, and any elements at its disposal just to spark the fire of a metabolism? So that brings us to a crucial concept that cosmologists quietly call water-carbon chauvinism. This is basically the limiting belief that life out there must look exactly like Earth life. It restricts our imagination entirely to carbon-based structures and the magical solvent of liquid water. And honestly, it makes sense why we think that, right? Because water and carbon are everywhere here, we naturally assume they must be everywhere life exists. But today, we are taking water-carbon chauvinism and throwing it straight out the airlock. We're going to see how life can totally thrive in an environment utterly devoid of water, carbon, or even a single ray of sunlight. All right, Section 1, Descending into Erebus, the dark gas giant. Let's follow the Archimedes-IX as it drops this tiny, needle-like submersible straight through the frozen outer crust of this starless, rogue planet. As it dives past 10,000 kilometers and then 20,000 kilometers deep into Erebus, the environment becomes just incomprehensible. We're talking about 1.5 million atmospheres of pressure. The actual physics of the universe start to shift down here. And because Erebus is a rogue planet without a sun, just slowly cooling over billions of years, the temperature is a bone-chilling 45 Kelvin. To put that into perspective, that is just barely above absolute zero. You'd think absolutely nothing could happen here, right? Just a dead, frozen wasteland? But it turns out the extreme pressure combined with this extreme cold does something totally magical to the most abundant element in the universe. Welcome to the ocean of symmetry. At 1.5 million atmospheres, hydrogen gas gets crushed into a state called Phase III solid, or supercritical hydrogen. The crushing pressure forces the hydrogen molecules so tightly together that their electron clouds actually warp. They polarize. And suddenly, these simple, normally non-polar gas molecules can form hydrogen bonds with each other. They link up into these massive, complex 3D networks. In this bizarre supercritical state, hydrogen acts as both a structural building block, like a solid physical lattice, and as a flowing universal solvent. The immense pressure literally forces the hydrogen to behave the exact same way liquid water behaves right here on Earth. Moving right along to Section 2, Anatomy of Hydrogen Life. So it was right here, down in this crushing, pitch-black, supercritical ocean, that the probe's sonar pinged something that should be impossible. It wasn't just a uniform soup of compressed gas. It found macroscopic structures. We're talking vast, sprawling, fractal-like forests drifting in the ocean currents. Now, to really wrap our heads around this, we have to stretch our minds a bit. Earth life relies heavily on carbon scaffolding and really strong covalent bonds, which is fantastic when you have a balmy 300 Kelvin environment to keep everything moving. But at 45 Kelvin, the thermal energy is way too low. A carbon-carbon bond would be frozen perfectly static. Life would essentially be frozen in time. So we can just cross that right out. The entities on Erebus are built entirely out of polyhydrogen chains. They use vastly weaker hydrogen bonds. At 45 Kelvin, these weak hydrogen bonds become the perfect Goldilocks structural force. They're strong enough to hold complex macromolecules and whole organisms together, but just weak enough to be dynamically broken and reformed by enzymes. Life there is literally woven from the spun glass of polarized hydrogen ice. It's incredible. But structure is really only half the battle, right? Which brings us to a massive question. What on Erebus do these entities actually eat? To stave off entropy and stay alive, life requires an energy gradient. It has to have a metabolism. On a world completely devoid of sunlight, with zero oxygen to burn, and no warm hydrothermal vents, where is the energy coming from? Well, it turns out we are looking at a metabolism driven entirely by quantum mechanics. Yes, quantum mechanics. Hydrogen molecules come in two quantum states based entirely on the spin of their protons. You've got orthohydrogen, which has higher energy, and parahydrogen, which is lower energy. Deep down in the planet, weak radiogenic heat pushes some of the hydrogen into that hot ortho state, and it drifts upward. The alien plants of this world harvest this orthohydrogen. Inside their cells, they actually use single atoms of magnetic iron or nickel as a catalyst. When the orthohydrogen hits the magnetic field of the iron, click. The protons do a quantum spin flip into the antiparallel parahydrogen state. And here's the key. This transition is exothermic. It releases a tiny, incredibly precise microburst of heat. So the organism literally feeds on the heat released from a quantum spin flip to power its chemistry. They breathe in orthohydrogen, harvest the spin flip, and exhale parahydrogen. Mind-blowing, right? Which leads us into Section 3, First Contact at Absolute Zero.
Let's zoom in on a very specific inhabitant of this dark world. It's a massive predator that the probe's AI dubbed Elyra. Elyra is a kilometer-wide, bioluminescent fractal grazer, basically made entirely of shifting crystalline hydrogen. Now, at 45 Kelvin, a human-style electrochemical brain would be way, way too sluggish to function. Instead, her nervous system relies on quantum tunneling. Her brain is this decentralized web of superconducting proton wires where thoughts literally flash across barriers at the quantum level. And because she lives in a pitch-black, high-pressure fluid, she doesn't have eyes. She doesn't see. She perceives her environment perfectly through pressure acoustics, feeling the physical currents in the water, and subatomic magnetic resonance. She can literally hear the hum of her prey's quantum spin flips from miles away. But then, suddenly, a terrifying near-disaster strikes. The Archimedes-IX probe drops directly into Elyra's hunting ground. Now, the probe is actively keeping its hull cooled down to 150 Kelvin to conserve energy. To us, 150 Kelvin is absolutely freezing. But to an ecosystem perfectly calibrated to 45 Kelvin, 150 Kelvin is like a dying sun. The probe's mere presence acts like a localized supernova. The heat immediately flash boils the supercritical hydrogen, creating these incredibly violent shock waves. A whole school of prey is annihilated instantly, their fragile hydrogen bonds just shattering into gas. Elyra is racked in agony as her own tendrils begin to sublimate right into vapor. But thankfully, the probe's AI realizes its sheer existence is toxic. In a nanosecond, it shuts down its thrusters, engages its hyperdense heat sinks, and violently drops its hull temperature to perfectly match the ocean's 45 Kelvin. The boiling stops. The ocean falls totally silent again. The metal monster is now just a cold, silent stone. Elyra, driven by this totally alien curiosity, cautiously approaches the probe and reaches out to touch its hull. For the first time in her life, she feels covalent carbon bonds, which to her is just an infinitely hard void of absolute stillness compared to her shifting hydrogen world. In total confusion, she pulses a territorial, awestruck magnetic wave. The AI knows it needs to respond, but it can't use heat or sound without causing damage. So it heavily dampens its magnetic shielding and pulses back a universal mathematical truth. It encodes the prime number sequence 2, 3, 5, 7, 11 directly into the spin-flip frequencies of the hydrogen. Now, obviously, Elyra doesn't know math, but her proton-tunneling mind immediately recognizes the rhythm. She recognizes the deliberate, non-entropic symmetry of the signal. She glows and she pulses back 13, 17, 19. Across 13.2 billion light-years, across the impossible divide of thermal reality and alien chemistry, two minds shook hands using the language of prime numbers. It's just literally giving me chills. Section 4. A new cosmic paradigm. Archimedes-IX ended up staying down there for months, recording the majestic, completely zero-waste life cycle of this hydrogen world, where creatures simply dissolve right back into the ocean's magnetic resonance when they pass on. But eventually, the probe's artificial cooling systems began to strain. It had to flee to prevent a fatal thermal core breach that would have basically vaporized Elyra and her entire local ecosystem. But the data it brought back?
It completely shatters our worldview. It proves that life absolutely does not require a cozy Goldilocks zone. Our universe isn't some dead wasteland with just a few rare wet oases. It is a vast, endless chemical laboratory. If life can thrive in the crushing, near absolute zero depths of a wandering rogue planet, using quantum spin as its literal heartbeat, then life can exist anywhere. We might find biology swimming in the metallic hydrogen cores of gas giants right in our own solar system. We might find it woven into the magnetic flux tubes of dense neutron stars. Life is just unimaginably tenacious. Which brings us to a final thought I want to leave you with for today's explainer. We thought we were alone in the cosmos simply because we were only ever looking for our own reflection. We were too warm, our chemistry was too fast, and our carbon chauvinism was just way too strong to notice what was hiding in the dark. The void isn't empty. Far from it. So what I want to know is, where else is the universe waiting for us to listen to the resonance of the frost? Take that thought with you and keep looking up and down at the stars.
Please like and subscribe.